Hello grade 9 students, this is now our last topic for quarter 1. This is all about solving problems involving quadratic functions. The most essential learning competency solves problems involving quadratic functions, and for the learning objectives to determine the steps in solving problems involving quadratic functions, to solve problems involving quadratic functions, and to apply quadratic functions in real-life situations. Let's start with our example number 1. Find two real numbers whose sum is 17 and whose product is 72. Okay, for the solution, let x be one of the numbers. Then 17 minus x is the other number. Yes, because if we're going to add 17 minus x and x, the sum is 17. And the product is 72. So therefore our equation is, okay, we just multiply x by 17 minus x. So we have here x times the quantity 17 minus x is equal to 72. So it becomes 17x minus x squared equals 72. And then we have here 0 equals x squared minus 17x plus 72. Okay, we transpose negative x squared and 17x. And by factoring, what are the factors of 72? Sum is negative 17. We have negative 9 and negative 8. And then by zero product property, we're going to equate x minus 9 and x minus 8 to 0. Solving for x, we have x equals 9 and x equals 8. So therefore, the two real numbers are 9 and 8. Okay, so that is how to solve problem number 1. Let's proceed to example number 2. The perimeter of a rectangle is 48 meters. Find the dimensions of the rectangle that will contain the greatest area. Okay, so for the solution, let L and W be the length and width of the rectangle. And then the perimeter P of the rectangle is P equals 2L plus 2W. That's the formula in finding the perimeter per rectangle. And since in the given, the perimeter is 48 meters, thus 2L plus 2W equals 48. Right? And we can still simplify this equation. Let's divide all terms by 2. So L plus W equals 24. Now express the length as a function of W. So from L plus W equals 24, we're going to solve for L in terms of W. So just transpose W on the right side, so it becomes L equals 24 minus W here. Then substituting the formula for the area of rectangle, A of width equals WL. This is the formula in finding the area of rectangle. Okay, let us now substitute L by 24 minus W. So we have A of W equals W times 24 minus W. So this is 24W minus W squared, or negative W squared plus 24W. And then by completing the square, right, we'll divide 24 by 2, then square it. 24 divided by 2 is 12. 12 times 12 is 144. So we have here now the equation. What we just did is we transform this quadratic function to its vertex form. Okay, negative W minus 12 squared equals 144. So from here, the vertex is 12, 144. Okay, so the vertex of the graph of the function is 12, 144. So this point indicates a maximum value of 144 for A of W that occurs when W is equal to 12. Right? So that's the maximum area, 144 square meter. When the width is 12 meters, then the length is, okay, substitute now. Since W is 12, 24 minus 12 is 12 also. So therefore, the dimensions of the rectangle should be 12 meters by 12 meters, so that it will generate the maximum area, which is 144 square meters. Okay, let's proceed to example number 3. The height h in feet of a ball t seconds after use toss upward is given by the function h of t equals 112 minus 16t squared. A. What maximum height will the object reach? And B. How long will it take the object to reach the maximum height? So, solution for letter A. The maximum height reached by the object is the ordinate of the vertex of the parabola parabola of the function h of t equals 112 minus 16t squared. By transforming this equation to completed square form, we have the maximum height is the ordinate, bali yung k. So transform natin to sa vertex form, yung k, that will be the maximum height reached by the object. Yan. So from here, we have h of t equals negative 16t squared plus 112t. We have h of t equals negative 16 times quantity t squared minus 7t. Factoring natin yan. Then, divide 7 by 2. 7 halves, square mo, 49 over 4. So, therefore, the vertex form of 112 minus 16t squared is negative 16 times the quantity t minus 7 halves quantity squared plus 196. What is k? 196. That is now the maximum height reached by the object, 196 feet. Yes. Okay, that is the maximum height reached by the object, yung k, pag naka-vertex form yung quadratic function. And for letter B, the time for an object to reach the maximum height is the abscissa of the vertex of the parabola. Okay, di ba sinob natin kanina yun? Sinabi natin, yung 196, that's the maximum height reached by the object. And what is the time for an object to reach the maximum height? Which is actually the abscissa. Ito naman, yung h, 7 abs, or 3.5. Okay, the object is at its maximum height after 3.5 seconds. So that is the answer for number 3. 196 is the maximum height. 3.5 seconds is the time for the object to reach the maximum height. 3.5 seconds. Okay, let's proceed to number 4. A garment store sells about 50 t-shirts per week at the price of 200 pesos each. For each 20 pesos decrease in price, the sales lady found out that 10 more t-shirts per week were sold. Write a quadratic function in standard form that models the revenue from t-shirt sales and what price produces the maximum revenue. Solution, let x be the number of additional number of t-shirts sold. And you know that revenue R of x equals price per unit times the number of units sold. This is our formula. Revenue R of x equals number of t-shirts sold times price per t-shirt. So number of t-shirts sold is 50 plus 10x, while the price per t-shirt is 200 minus 20x. We're going to multiply that by FOIL method. So we have negative 200x squared plus 1000x plus 10,000. Then if we transform the function into the form, to the vertex form here, y equals a quantity x minus h squared plus k, it becomes r of x equals negative 200 times quantity x minus 5 halves squared plus 11,250. So the vertex, you can see in the equation, 5 halves, 11,250. So thus the price of the t-shirt to produce maximum revenue can be determined by P of x equals 200 minus 20x. Yun, the price per t-shirt. So just substitute x by 5 halves. 20 times 5 halves is what? 50. So 200 minus 50 is 150. So thus 150 pesos is the price of the t-shirt that produces maximum revenue. Okay, let's proceed now to exercises. Find the maximum or minimum value of each quadratic function. Write your answer in the space provided for. Okay, so as you can see, if a is positive here, it goes upward. So numbers 1, 2, 3, 5, these are parabolas that goes upward. Only number 4 have negative, or number 4 has a negative value of a, which is negative 1. So number 4 is a parabola that opens downward. So when the parabola opens upward, it has a minimum value, and when the parabola opens downward, it has a maximum value. So for number 1, the minimum value is 3. And for number 2, the minimum is 4. For number 3, the minimum is negative 2. For number 4, the maximum is 2. And for number 5, the minimum is negative 5 over 6. Next, find the dimensions of the largest rectangular field that can be enclosed with 40 meters of wire. Answer? Number 1, 10 meters by 10 meters. For number 2, 70 meters of wire, it should be 17.5 meters by 17.5 meters. And for number 3, 120 meters of wire, 30 meters by 30 meters. For number 4, 200 meters of wire, should be 50 meters by 50 meters. How about number 5, 90 meters of wire, should be 22.5 meters by 22.5 meters. And let us have also here multiple choice exercise. Number 1, find two real numbers whose sum is 20 and whose product is maximum. Is it A, B, C, or D? What's your answer? The answer is letter A, 10 and 10. 10 plus 10 is 20. The product is 100. Okay, it has a maximum product. Next, number 2, find two real numbers whose sum is 12 and whose product is minimum. Answer is D, 1 and 11. 1 plus 11 is 12. 1 times 11 is 11. Okay, product is minimum. Number 3, the perimeter of rectangle is 40 meters. Find the dimensions of the rectangle that will contain the greatest area. Is it A, B, C, or D? The answer is B, 10 meters. Number 4, what is the maximum area of the rectangle if the perimeter is 100 meters? 100 meters is the perimeter. The answer is C, 625 square meters. And number 5, what is the largest rectangular area that can be enclosed with 20 meters of fence? And the answer is A, 25 square meters. Thank you very much for listening. This is the topic, application of quadratic functions. Okay, see you next time. Goodbye.